Alright, this is video 6.2, and we're going to look at something called molar mass and mole conversions one step. So make sure you have your pencil and paper out and ready to pay attention to this and follow along. Here we go. Alright, we're going to start with molar mass. Alright, well, what is molar mass? Well, molar mass is this. If you have 1 mole of any pure substance, and a pure substance, so 1 mole of any pure substance. Now let's remember what a pure substance is. A pure substance is either an element, remember that's 1 capital letter, or compound. Okay, remember that's a bunch of capital letters put together. Okay, so if you're looking at the formula written out, we're looking at a compound. So that's a group of elements chemically combined. If when they're written out, right, you'll see more than 1 capital letter. So 1 mole of any pure substance element or compound. All right, and we actually probably should say the mass. The mass of, sorry about that, I should put that there. The mass of 1 mole of any pure substance is the molar mass. Okay, so let's remember what 1 mole is again. 1 mole is equal to 6.022 times 10 to the 23rd. All right, compounds, atoms, particles, whatever you want to put here. Okay, so when it comes to chemistry, the molar mass, we look at elements and we look at compounds. And how we do this is, let's say that we want to look at the molar mass of hydrogen. So the molar mass of hydrogen. Well, what we do is, we say that we have 1 mole of hydrogen. And what is that equal to? Well, if you look at a periodic table, which we have here, we've talked about these numbers down here as being the average atomic mass. Okay, and that still is true. Yes, this is the average atomic mass. However, when you have a mole of any of these substances on the periodic table, not only is this the average atomic mass, but this is also the molar mass. Okay, this is also the molar mass. So for hydrogen, you see on this periodic table, it goes a little further than the ones you have, 1.0079. If you look at your periodic table, it just says 1.0. So the molar mass of hydrogen is 1.0. And we write this grams. And if we're talking about molar mass, it's grams per mole. Sometimes we'll just quicken it up and say the molar mass is 1.0 grams. But grams per mole, all right, that is the molar mass. So every time we have 1 mole of hydrogen, it's 1 gram per mole. If we look at something like helium, and we'll jump back to our periodic table here, we jump over to helium, 4.026. On your periodic table, we round it to 4.0. And so the molar mass of helium is 4.0 grams per 1 mole. So every time we have, you can put a 1 down here if you want, every time you have 1 mole of an element on the periodic table, that average atomic mass in grams is the molar mass. Alright, well, what happens if we have something like the compound here? What is the molar mass of NaCl? Well, first of all, when we say this, we mean we have 1 mole of NaCl. So we look at this and we go, well, how many sodiums do we have here? We have 1 sodium. So for sodium, if we look at our periodic table, sodium's right here. All right, it's 22.990. I'm going to use your periodic table though, and it says that sodium's molar mass is 23.0. I just round it, grams per mole. All right, for chlorine, and there's just 1 chlorine because there's the subscript here is just 1 if it's not written. For chlorine, we'll jump over to our periodic table, and it says 35.453 for chlorine. On your periodic table, we round that a little bit, and that's okay. So 35.5 grams per mole. Now this question does not ask just sodium or chlorine, it asks for the compound sodium chloride. So what are we going to do with these? Well, since there's just one of each of these, all we're going to do is just add these together. So when we add these up, and we'll just do that quickly here, we get 58.5 grams per mole. And then we have the molar mass of a compound. Let's do another one here, except you see this one, ooh, it's got a lot of numbers here. That's okay. What's the molar mass of this? So once again, we're saying we have 1 mole. This is iron. Ooh, there should be a 4 here. It should be PO4 too. All right, sorry about that. All right, so this is iron 2 phosphate, and we have 1 mole of this. So what is its mass? Well, we first look up iron. Go to our periodic table. And iron's right here, 55.845. On your periodic tables, it just says 55.8 grams per mole. Okay. Next, let's look up this P, which is phosphorus. Phosphorus is 30.974, which on your periodic table, we round to 31.0 grams per mole. And then lastly, we have oxygen. And on your periodic table, it is 16.0 grams per mole. Here, I'll show it on mine real quick. There it is, 15.999. So we'll just say 16. Now, the difference in this one is, look carefully. We have subscripts here. So what you need to do if there are subscripts in a formula is you have to multiply by that many. Well, we have 3 irons right here. So I need to multiply this by 3. When I do that, my number comes out to be 167.4 grams per mole. Alright, for phosphorus, you got to be careful. You look inside the subscript first. There's nothing written here, so it's a 1. But there's a 2 outside. Remember, that 2 multiplies in. So we have 2 phosphorus. So 31.0 times 2 is 62. Sorry about that. 62.0 grams per mole. Lastly, be careful with this oxygen. We have a 4 here, but a 2 outside the parentheses multiply, so we actually have 8 oxygens. So 16 times 8 is going to give us 128.0 grams per mole. And now we did just like the last one, we add it. So we got a 0.4 here. Let's see, that's going to be 17, carry our 1, 12, 14, 15, carry our 1, 3. So the answer to this is 357.4 grams per mole. So yes, I do want to see your work. All right. Let's keep going. All right. Mole conversions, one-step problems. All right. When I say a one-step problem, this means a one-step phlegm chart. So we're back to phlegm charts. Here we go. How many atoms are in 3.2 moles of copper? Well, if you remember the other day, 1 mole is equal to 6.02 or 22 times 10 to the 23rd atoms, particles, molecules. In this one, we're looking for atoms. So 3.2 moles of copper is what we start with. I want to know how many atoms of copper are there. Okay, if you remember our phlegm chart, we always start off with what we're given here in the top left, 3.2 moles copper. Now, no numbers yet, but we're going to come down here. All right, we have to cancel out moles of copper because we don't want it. And what do we want to get to? We want to get to atoms of copper. And we can do this in one step. If you remember, this section here is called the conversion factor. How do we convert, or how do we change from moles to atoms? How are these equal to each other? Well, we figured it out the other day. That 1 mole is equal to 6.022 times 10 to the 23rd atoms. On top we multiply, and on bottom we divide. So 3.2 times 6.022 to the 23rd. All right. And when we get this, our number comes out. I'm going to write it down here because I'm running out of room a little bit. We get 1.9. I'm rounding a little bit. Times 10 to the 24th atoms of copper. How do I know it's atoms of copper? Because look what happens to moles, remember? Units top and bottom cancel. Multiply on top, divide on bottom. And there's a one-step Flim chart. All right, we got another one here. How many, this time, molecules are in 5.3 moles of carbon tetrachloride? Just to step back for a second to first semester, the term molecule is only used for a compound that is covalent. Okay? The term molecule is only used for compounds that are covalent. How do I know this is covalent? If you remember, covalent compounds, two or more non-metals. Oops. Non-metals placed together. Well, carbon's a non-metal and chlorine. So this is known as a molecule. Okay? So, let's do a Flim chart here. I've got 5.3 moles of CCl4. I don't think I pointed this out yet. It's kind of fun, or at least funny. The mole is abbreviated. Instead of writing MOLES, we just put MOL. I have no idea why they just dropped a couple letters, but they did. So we have 5.3 moles of CCl4. All right, I want to know how many molecules. So here we go. I want to cancel out moles of CCl4. And I want to go to molecules of CCl4. Okay, so we have a mole and a molecule here. Well, how does this work? Well, 1 mole is equal to 6.022 times 10 to the 23rd molecules. Once again, this is called a conversion factor. So 1 mole goes down here, 6.022, if I can use my pen properly, there we go, times 10 to the 23rd. Again, if you just want to do 6.02, okay, that's fine. We multiply on top. Divide by the 1 on bottom, so 5.3 times 6.022 times 10 to the 23rd. Divided by 1, and we get the grand total of 3.2 times 10 to the 24th. Moles cancels out. We're left with molecules of CCl4. Sorry about my handwriting. All right. All these are one step, so let's do another one-step Flim charts. Okay, if you have 8.9 times 10 to the 22nd formula units, abbreviated FU, no, don't laugh, all right? Let's abbreviate F.U, okay? It's the only time you're probably allowed to say that in a class. But formula units of KCl, how many moles of KCl are present? Okay, this time I am giving you 8.9 times 10 to the 22nd F.U formula units of KCl. Alright, I do not want formula units of KCl. The question this time says, how many moles of this do I have? Okay. Oops, sorry about that. Alright, with all of this being said, what's our conversion factor? Well, a conversion factor still is 1 mole is equal to 6.022 times 10 to the 23rd. In this case, formula units. The biggest thing here with students they mess up on all the time is where you put your numbers. Make sure you pay attention to your units here. What's the number with mole here? The number's 1. So this time the 1's going to go on top here. And this 6.022 is actually going to go on bottom. It's a 6. So, how do you know where to put it? Well, just make sure you do the steps in the Flim chart. put your given here, and then put your units down, then go back and put your numbers. So we know our conversion factor is 1 mole is equal to 6.022 times 10 to the 23rd formula units. So this time 1 goes on top, 6.022 on bottom. On top we multiply, on bottom we divide. Now this is usually the type of problem if students do mess up with their calculators and doing scientific notation. This is usually where I see it at. The answer to this should be 0.15 moles of KCl. If you got something different than this and you have these numbers, you probably put in your calculator wrong. Call me over, I'll help you out. Alright, this problem here, if you have 23.2 grams of carbon monoxide, how many moles of carbon monoxide do you have? Alright, 23.2 grams of CO. The question doesn't want grams. It says how many moles. And 1 mole is equal to, now, don't put down 6.022 times 10 to the 23rd. That is true. However, we're talking about mass now. And if you remember, 1 mole is equal to the molar mass of the compound or element. We're talking about carbon monoxide. So, yes, you have to go through and you have to figure out, well, carbon on your periodic table is 12.0 grams per mole. And oxygen is 16.0 grams per mole. And if you look, there's no subscripts here, so they're both 1. So we can just add them up. And so the molar mass here is 28.0 grams per mole. So what's my number I put here for a gram? I'm going to put 28.0 grams. For how many moles? 1 mole. For every 1 mole, you have 28.0 grams. This is going back to molar mass. So this right here is your conversion factor. We're going to multiply on top, divide on bottom. So 23.2 times 1 divided by 28.0. And we're going to get the grand total of 0.829 moles of carbon monoxide. Biggest trouble here when you have grams is people start putting that 6.022 number, that Avogadro's number, if you remember that term, Avogadro's number. But don't put it here. When you have grams, you're using molar mass. So when you see grams, think periodic table, okay? When the mole and gram are together, grams are periodic table. Mole is 1. Alright, the problem here, this time if you have 0.112 moles of nitrogen dioxide, how many grams do you have? We want to cancel out moles of nitrogen dioxide. We want to go to grams. Once again, we have this gram and mole together. Uh-oh, I've got to go to my periodic table. Nitrogen on the periodic table, molar mass is 14.0 grams per mole. Oxygen is 16.0 grams per mole. 1 nitrogen, so we don't have to do anything to that, but we have 2 oxygens, so don't forget we have to multiply this by 2. Alright, multiply that by 2, so when you do that, you get 32.0 grams per mole. You can multiply this by 1 if you want to. I'm just going to do that so we have them over top of each other. And then we are going to add these up. So when we add these up, we get 46.0 grams per mole. So we have our mass, 46.0 grams per, how many moles? 1. 1 mole is equal to that mass in the periodic table. This is your conversion factor. So this time, 0.112 times 46.0 divided by 1, and you get the grand total of 5.15 grams